Hi guys! Welcome to the cellular respiration lab. You've already set up your microrespirometer. It looks like this guy. And so now this is the video about what exactly it is you're going to do with these. You should have 3 for your group. If you made 4, you have an extra in case one of them turns out to not be functioning properly, which is helpful. But you only need 3 to do this. And you're going to do what I'm about to do. You're going to do this 3 times. Once with the control, which is the baked seeds, once with the non-germinated seeds, and then once with the germinated seeds. In this lab, I'm just going to show you how to put together one of them because then you do the exact same process for the others. I'm going to use germinated or non-germinated seeds, which are just seeds right out of the package. And they're right here. You'll notice the goggles. You get to wear the goggles. This is by far the most dangerous lab we do all year, which I know seems weird because we're dealing with turnip seeds. But the reason it's the most dangerous lab we do all year is because we use NaOH, and we are using 15% KOH, which is, or NaOH rather, which can really do some damage to you if you get it in your eyes or on your skin. And so when you're actually messing with it, you are also going to get to wear very fancy latex gloves. I'll see if I can dig up some non-latex ones. I am going to ask that you guys appoint one person in your group to put on the gloves and move around the sodium hydroxide. And then save the gloves because I don't have that many of them. And so assuming, of course, that you haven't gotten any of it on the gloves. If you got some on the gloves, throw them away, no big deal. But if the gloves are still good to go, you're going to wear them for about 30 seconds. Then take them off and leave them on the table so that the next group can use them. It just saves on the waste for me. So at this point, you have built your microrespirometer. It looks like this. You have a plug of cotton down here in the bottom, or I guess the top the way I'm holding it. And that plug of cotton is the absorbent cotton. And then we're going to remember that we said this in class. We're going to put 1 single drop of sodium hydroxide on that absorbent cotton, and then we're going to use some non-absorbent cotton to protect the organisms from it. Because just like it will hurt you, it would hurt them. And so in case you're curious what that reaction is, I wrote it on a handy little card for you. And so the NaOH is what you're going to put 1 drop on the absorbent cotton. The CO2 is what the organisms will produce, in this case we're talking about seeds, as they go through cellular respiration. And then the Na2CO3, okay, this is the solid that is produced through this reaction that then gets stuck in the cotton, because remember the whole goal is we want to be able to monitor how much oxygen these little guys are taking in, and the trick is that with cellular respiration you take oxygen in and you give CO2 out. Well, if we're monitoring gas production and we don't really have a way to monitor what's coming in versus what's going out, which is our experimental setup, we have to do something about that production of CO2, and so we trap it in this solid. Water's also formed as a byproduct. We trap it in the solid in the cotton so that then the only gas movement we have is the gas going into the microrespirometer. We don't have gas leaving the microrespirometer. So that's the equation. That's why we're using NaOH. So at this point, what you need to do is, first item of business, the first item of business actually, is to get one of your green tubs. Okay, let me show you. Green tub. You need to fill it up as high with water as you can. And it's just room temperature water, and then you need to like set it on the counter while you prepare all the rest of this stuff. It just needs to sit there, and the temperatures just have to work themselves out. So get your green tub, set it on the counter, put as much water in as you can without it overfilling or overflowing from my little handle area. That's my low point. That becomes very important because this whole thing happens underwater. Once you have established your tub, you're ready to finish up the production of your microrespirometers. So you put on your gloves. I'm going to have 1 station that I will guard closely where our NaOH is going to be. If you are not wearing goggles by the time you get to me, you will get frowned at and yelled at and sent back to go get goggles. You have to be wearing goggles for the entirety of this lab. I love your eyes, and I'd like for you to have them when we're finished. So here we go. Next to the test tube is going to be a skinny pipette. You need literally 1 drop. Now, it's not possible for you to actually get 1 drop out of my test tube, which is where this stuff is hanging out. And so I get it that you're going to end up with more than 1 drop up in your bulb. But there it is. Okay, it's up in my bulb. And then what you want to try to do is to get all the way down to the cotton and get none of this stuff on the side of your microrespirometer, because if these seeds come in contact with it, they will die, which will be very, very cumbersome to analyze in your data. So you go all the way down to the bottom without touching the sides, and you give it a squeeze, and you get one drop in the bottom. Okay, brilliant. You leave your little pipette there. Okay, I know it looks like nothing's changed, but something has. There we go, sorry. I know it looks like nothing's changed, but something has, and that is that we've added that NaOH. So now we need to add the little protective covering of non-absorbent cotton to the top of it, and that's just going to provide a barrier for our organism. It's also going to manage to push down. You can see I got a drop of the NaOH on the side there. That's bad. And so the other thing it's going to manage to do is push down anything that I managed to get on the side. If you feel like you really have an awful lot of stuff on the sides, and I feel like I might here, you can actually get another little dab of the absorbent cotton and push that down the sides, and it'll kind of pick up anything that you may have let go through. So again, those cotton balls are in your inquiry tub, or they should be. So if you feel like you want to add a little bit more of the absorbent cotton to the top, go for it. And like I said, I'm going to put a little bit more in there just so you guys can see. Once you're done with the once you're done with the NaOH, you can take your clothes back off. They are kind of cumbersome to work in. Okay, so I'm adding just a little bit more of my absorbent cotton to the side. I'm just making sure that I'm getting anything that was on the side of my microrespirometer off. So we're jamming that down into the bottom, like that. You can actually see, I don't know if the video is good enough for you guys to see, but you can actually see the NaOH kind of getting kind of soaked up a little bit into that absorbent cotton. All right, once that's done, now we're ready to put on the non-absorbent cotton. And this stuff, here it is, cotton. This is the stuff they used, like I said this in class, I think, they use underneath your cast if you ever get a cast, okay? It's just not absorbent. So I'm going to take my gloves off real quick. Like I said, once you're done using the NaOH, you're welcome to take your gloves off too. I'm going to cap that so I don't spill it on myself. For the non-absorbent cotton, you just need a little bit. Unfortunately, when I bought this 3 years ago, I had to buy a pound of it, which is what this is. And so this is going to be enough to last my entire career. So you don't need much. Okay, here we go. Now, I take this wad, and in fact, this wad is about 3 times or 4 times as much as I need, but that's okay. I'm going to bust some of it off, roll it up. Okay, and the whole idea is that because it's cotton, the gas can move through it, okay, but the organisms cannot. So we'll be able to see the organisms, or we'll be able to monitor how much oxygen the organisms are actually taking in. So there we go. So the key is we're going to be measuring respiration by mass, and so you need to know the mass of the seeds that you put in here, and that's our next step. And so actually I just lied, that's not your next step. One of the things we want to do, because we're monitoring this based on fluid movement through your capillary, because of the properties of water, this can be very sticky. This fluid can be very the microrespirometer can be sticky, and so what we want to do is lubricate it, and the way we lubricate it is just with a beaker of soap water. And so because I forgot about this and I didn't prepare it, I'm going to do that real quick now, but I'll have a place for you guys to have just soap water. And the whole idea is just to lubricate the inside of that capillary tube. So I just made some quick soap water. Here is key, because there's a good chance, and you can even see it in mine. Right now I have not stuck this in the water yet. That is that extremely caustic NaOH. This is why I'm making you wear goggles, because if you push down on this, you push it on your plunger, there it is. See all that stuff coming out? So as you push down on this, you need to make sure that you're doing it in the direction of the sink. Don't point it in anybody's face or skin or clothes or anything like that. When you're doing this, you want to make sure that you're pushing toward the sink. Then you're going to pull, so I'm going to do that. Okay, pushed all of that gunk out. And then I'm going to suck up a little bit of my soap water like I said, it's just a lubricant, all the way up until I can see. If I go too high, my soapy water is going to get all the way into my cotton, and that means that my cotton is no longer going to allow oxygen to pass through it, and it's not going to work. So I'm going to bring it all the way up to here, my water all the way up to here, and then I squirt it back out into the soap cup. And that's it. And the whole idea is just because we need to be able to lubricate that capillary tube. If you have air bubbles in your capillary tube, you probably are going to know at this point, because you'll start to see air bubbles fizzing up from this inside. If you start to see air bubbles forming in here as you're doing this, that's how you know you should set this one aside and just grab a different microrespirometer. If you don't have an extra one, you can just add glue to try to fix it, or you can start over, whatever you think is easiest at that point. All right, so we've lubricated the inside of our capillary tube. Great. Now we're ready to add our seeds, and it says to add 0.5 mils. So if you look at the side of your capillary tube, right now we're at 0.1, and so according to this we would go all the way up to 0.6. It doesn't really matter to me how much you put in there. I think 0.6 is a little bit much, or at 0.5 bringing us up to 0.6 is a little bit much. What ends up happening if you have too much is that the rate of respiration is so high that your little dot gets sucked down into your cotton down here, which is troublesome. So what I want you to do is find the mass of this thing all put together first. Mine's 3.4 grams. Then you're going to put some seeds in there. I would say maybe 0.3 mils worth of seeds. And then you're going to find the mass again, and you're going to be able to tell what exactly it is, the mass that you are actually using in seeds. So that's 3.3. I'm going to throw some seeds in there. They'll be in their little petri dishes, so you just need to go to the appropriate petri dish. And they drop everywhere, and that's okay. The ones that have been germinated are actually going to have little plants growing out of them, which are super cute. There we go. So I went up to 0.4. Let's see if I twist it. There you go. You can see it. I went up to 0.4. I'm going to put the little stopper back inside of it. Okay, it looks like that. In your book, it says to put the plunger at exactly 1.0. I say just put the plunger in until you hit the seeds. Don't squish the seeds, or obviously that's going to mess with your data as well. So then you put that guy back on your balance. I have a balance right here. That's what I keep setting it on. And you say, okay, what is the mass of the seeds I'm using? I'm actually going to get our AP Bio balances that go to the hundredths place for this, because I want you to be able to do this pretty precisely. Seeds weigh very little. And so here we have 0.1 grams. This is 0.1 grams. I have it on my just balance that just goes to the tenths. And so I want you guys to be able to be a little bit more specific, or a little bit more accurate than that. So now I'm ready. The next, so I've built my microrespirometer. I have put in my NaOH so that as the gas is produced, we're not actually measuring that in our little capillary up top. The next, I figured out the mass of my seeds so that I'm able to properly interpret this. The next thing I need to do is tape my piece of cardstock to my capillary like this. This is not tricky, but this is actually what you're going to be recording your data on. Scotch tape in your inquiry tub, and you want to make sure you use clear tape. There's also masking tape in your inquiry tub, but you don't want to use that. And so what you do, you just tape it on. I suggest 2 pieces. Works great. Looks like that. Okay, now we are ready to submerge this thing. The whole thing, now here's the funny part that makes this a little bit more difficult. This entire lab gets to be done underwater. You're like, well, there's paper attached to that. How's that going to work? Well, it's going to work very carefully. The other trick is that this thing floats. So you have to sink it. You have to sink one end of it while keeping this above water, because this is where air is supposed to come in. And you have to give it some time to kind of equilibrate. So once you have gotten to this point, you're going to use metal washers or hex nuts. Okay, can also work to literally sink this in your tub. So I'm going to put this in my tub the way I want it done, And then I'm gonna move the camera over there so you guys can see it. So I sink this in my tub. Wait for it, wait for it. Your cardstock might get wet. That's okay. Let's see. Stay. This takes a fine art. Sometimes it's helpful, and mine is doing this right now, to actually, I will show you guys this here in just a second, to actually tape the card down so that what you need to have submerged is actually the seeds. That's what needs to be underwater. It doesn't matter if the cotton is underwater or not, because that's not what's actually respiring. Okay, let me show you what I did. Okay, so let me see if I can figure this out. There they are. You see that I had one of them in there earlier, the one on the right that does not have a card attached to it. I stuck in there. It also has no seeds in it. But the one that I just made is this one. And I have submerged the seeds underwater. I've anchored it down with my hex nut, and then I have the card that's sticking out the side. So now we let it sit. And we let it sit for everything to just get happy and normal. Meanwhile, you are going to prepare your other two, because you should also have a germinated seed one and then a control one. There you go. Now we're ready. Okay, after you've let this sit. How long it sits depends. Let's see. How long it sits depends on how much time we have in class. It would be nice to let it sit for about 10 minutes to just kind of let everything get normal. If that's not realistic for you, then that's not realistic for you. The next thing you need to do is when you start your experiment, when you actually start your data collection, all you need to do at this point is give yourself a marker in your capillary tube in order to monitor the oxygen consumption, so the air that's moving in. And then at 1 minute increments, all you have to do is, using your pen, take an indicator. Sorry guys for the really awesome camera work. All you have to do is say, okay, we started here with my marker. After 1 minute we were here, 2 minutes we were here, and so forth. Use a Sharpie, because a Sharpie will write on the Scotch tape if you're on the Scotch tape or whatever. So I'm going to show you the easiest way to mark this, but because I don't have a prehensile tail, it's very difficult for me to hold that thing up while also putting in a drop of my red dye. So we're going to use dye. Red, blue, green, I don't care, pick your favorite color. You're going to get some color, your food coloring. And that dot is what you're going to monitor the movement of on your cardstock in order to make this work. And so what you do, because this is kind of messy, you don't want to get the red dye all over the white cardstock, or it's going to be very hard for you to record data. And so what you do is you get a piece of paper and you slip it behind your capillary tube like this. So for that reason, I would recommend not putting tape right up to the very top of your capillary tube. So it looks like this, and then this will stain your clothes, so be aware, don't do that. Okay, don't squirt it at somebody. Be careful with it. Because it's a capillary tube, all you have to do is produce a drop right here and touch it to the top of the capillary tube, and it'll suck it in. Now you don't want to make too big of a drop, because if you fill up the entire capillary tube, that's not very useful. I put the piece of paper towel so that if I make a mess, which is likely, that the paper towel will absorb it. So I just have, you can see the tiny drop. I have a tiny drop. It's too big. You do not squeeze the food coloring container. You just touch it to the top as such, and you wait a second, and it will go in, or at least some of it will go in. If it doesn't seem to be going in by itself, you can pull ever so slightly at the plunger and it will suck it in. Okay. Here we go. Pull ever so slightly on the plunger. Oh, there it goes. Teeniest, tiniest drop ever, and yet when it actually goes into the capillary tube, look how giant it is. It's actually quite large, and in fact, I think I have a little ruler here. The thing is actually 4 millimeters long, which brings me to another point. Because you're doing this and it's submerged in water, and you're collecting data, you need to be consistent about where you're marking on your cardstock in relation to the red dot. Because if for the first 5 minutes you mark the top of the red dot, and for the next 5 minutes you mark from the bottom of the red dot, and then we're measuring distance that this has traveled as an indicator of respiration rate, you have just introduced a huge error. And so you just want to be consistent, and it doesn't matter if you always measure from the top of the dot, if you always measure from the bottom of the dot, you can see it. Right? It doesn't matter where you measure from, but you need to measure from somewhere, and you need to be consistent about it. So you go through, you do it for the number of minutes indicated. Every time you do it, you make a mark. Let us suggest that you've put so many seeds in there that you are losing track of your red dot down here at the bottom. I'm actually noticing as I'm doing this that some of my red is getting stuck on the side of the tube. For that reason, I'm going to indicate that you should always measure from the bottom of that red dot. I think that makes the most sense because the dot is actually getting smaller as it's going down, which is pretty interesting. So you're going to always measure from the bottom. We'll go with that. If you get to the bottom and you're not done with your experiment, you don't quit. You get out your towel again. Okay, you get out your food coloring again, and you add another dot. As such. And then you start measuring from the new dot, okay? And you can do it on the other side of the cardstock or something like that. It's only happened a couple times since I've ever done this lab where kids have literally run their red dot all the way into the cotton and had to add another one, but I just want you to be prepared for that scenario if it actually comes up. So you go through, you monitor your dots, and then you go back to your data analysis component. It tells you how to actually turn this into rate of respiration. Okay, that's what you're actually trying to do. You're trying to do this rate of respiration. Now, you're only doing one trial each, which means a lot of the statistics that I normally make you do don't apply because you have to have multiple trials for that to work out. And so it tells you in your notebook what it is that you need to do. There is a cover page for this lab as well, but I think we'll address everything else that you need to know in class, but this is the general procedure. Do remember that you're adding this red dot when we're underwater. You're not doing this out here. I'm doing it out here because I can't hold all of this stuff at once. It just doesn't work out. Okay, I hope that makes sense. Thank you so much for watching my video. Don't forget your goggles. I have them for you, obviously, but don't forget to put them on your face. Otherwise, it would make me very sad. That's it. Have a good day. I'll see you in class. Bye.